Graphs. Lesson 1, Compound Inequalities and Set Builder and Interval Notation Review. At the end of this lesson, you'll be able to solve compound inequalities. You'll be able to graph compound inequalities on a number line and write an inequality using Set Builder and interval notation. Without further ado, a set is a collection of unique elements. Elements in a set do not repeat. So if you're asked to list a set of elements, don't put a number in there twice. Sets may be described by roster, by set builder notation, by interval notation, by graphing on a number line, and or by Venn diagrams. We're going to look a little closer here at set builder and interval notation. Roster is just when you list everything. Set builder notation is a mathematical shorthand for precisely stating all numbers of a specific set that possesses a specific property. R stands for real numbers, Z for integers, and N for natural numbers. These types of numbers you learned about back in pre-algebra, where you have X is an element of integers such that 2 is less than or equal to X is less than or equal to 6. The vertical line means such that. The funny looking E, which looks like an E, it's not really an E, but it means is an element of. Okay? And because you've got the equal signs and the less than, it means that it includes 2 and 6. This next one, X is an element of integers such that X is greater than 0. That means anything greater than zeros. It is possible to use a colon instead of a bar to separate the definition of what type of numbers you're looking at and the restricted areas or ranges. Okay, both mean such that. Now, when we look down here at these two, we have X is an element of integers such that 4 is less than or equal to X is less than or equal to 30. On the right, we have X is an element of real numbers such that 4 is less than or equal to X is less than or equal to 30. What's different? Remember that integers, what are integers? Those are numbers that do not contain fractions. They are 4, 5, 6, etc. Real numbers, on the other hand, cover the entire spectrum. It's 4, 4.001, 4.5, 5 3/4, etc. Just so you know, natural numbers are integers that start at 1 and go up. They're the positive integers. So these two sets are very different. The one on the left has a finite number of elements. I can count all the elements, 4, 5, 6, 7, 8, etc. The right-hand side, because it includes all possibilities, all decimals, it's an infinite set. Now, interval notation. In math, we get to be very lazy. So interval notation is a connected subset of numbers. Interval notation is an alternative to expressing your answer as an inequality. Unless specified otherwise, we will be working with real numbers. Now, when you have a parenthesis, that means not included or open. When you have a bracket, it means included or closed. So the inequality 2 less than or equal to X less than 6 can be written in interval notation as bracket 2 comma 6 parenthesis. You should, yes. Hang on. Let me pause this. Sorry about that. Okay. You should have been exposed to both of these formats in previous math classes, particularly in Algebra 1, since on the Virginia SOL, your inequalities could be written in interval or in set builder notation. Now, using the description to graph the set of numbers on a number line and then write it in interval notation. The set of all real numbers between 1 and 5. That means we're not including 1 and 5. So we use an open point on the 1 and open point on the 5 and parentheses when we write our interval notation. The next one here is the set of all real numbers from 1 to 5 inclusive. The word inclusive means right here that we are going to include 1 and 5. So we have to have solid points at 1, a solid point at 5, and then we use brackets. Now, the next one, the set of all real numbers greater than 1 and less than or equal to 5, we have an open point, okay, at 1 and a closed at 5. The set of all real numbers greater than or equal to 1, if it's equal to 1, then it's got to be a closed point, and less than 5, an open point on 5. And so we use a bracket and a parenthesis. The set of all real numbers greater than or equal to 1. Here, we've got a solid point on 1, a line with an arrow that says it goes forever. Well, if it goes forever to the right, we are going towards positive infinity. Number 5 is the set of all real numbers less than or equal to 5. Well, that means that we are less than or equal to 5. Let me move this guy over here. So we've got a solid point. Our arrow points to the left. When we do our interval notation, it's negative infinity to 5. Remember that negative infinity is the smallest number and infinity is the largest. Now, for some intervals, it is necessary to use combinations of interval notations to achieve the desired set of numbers. Consider how you would express the interval all numbers except 13. Well, that means that x is less than 13 or x is greater than 13. In interval notation, that would say we're going to go from negative infinity up to, but not include 13. That's what the parenthesis means. The u is a fancy way of saying or. Parenthesis says we're not including 13, but then the infinity says we go on to infinity. Notice that negative infinity and positive infinity always get a parenthesis because we can't put a number on those. Okay? Consider expressing in interval notation the set of numbers which contain all numbers less than 0 and also all numbers greater than 2 but less than or equal to 10. As an inequality, you should be able to do x is less than 0 or 2 less than x less than or equal to 10. If you think about this, in interval notation, we're coming from negative infinity to x, and then we're coming up to 0. So therefore, we've got negative infinity to 0. The or is our u. Then we have a 2, but x can't be 2, so we should use a parenthesis. And then it goes up to 10, and oh, it can be 10, so we use a bracket. Now, you've got numbers 1 through 12. These are some questions just to see how you're doing with this whole idea of inequalities, number lines, and interval notation. Try answering these 12. Pause the video, and then we'll come back, and I'll go through the answers rather quickly. Okay, you're back. Let's start going through these. The number line graph would be best described by which statement? Well, you have a solid dot, open, solid. Solid, solid, open, solid. The numbers all match. Both appear to be correct. And in fact, both answers are correct. No, says the goose. Number 2. And some of the goose stuff is just for comic relief or, I don't know, boredom relief. All numbers from negative infinity up to and including negative 4, as well as all numbers greater than positive 1. Which statement best describes the situation? From negative infinity up to and including. I need an equals. I need an equals. I need an equals. And this says real. As well as all numbers greater than positive 1. All numbers greater than positive 1. Oh, these first two say that it could be equal. So it must be this last one. Number 3, all numbers from -3 up to and including +7. From -3, so it doesn't include -3. That means, whoops, let's give myself a pen color. So that means this doesn't work, and this doesn't work. So that leaves, oops, this one. Which statement below is the correct set builder notation for the situation depicted in this number line? Okay, again, we've got a solid at -9, we're good. We have an open at -5, that says -4. And this says that -5 should be solid. So notice, these are ways that you all can learn to take multiple choice questions. Start looking through, start figuring out which ones can, which ones cannot be. Okay. Eliminating wrong answers is as good as picking right ones. It cannot equal it cannot equal 9. So that means I've got this number line here that looks like this. So it's coming from -infinity, and it's going to +infinity, but it doesn't include 9. So I have to take a look. This first one, less than 9, greater than 9, -infinity to 9, 9 to +infinity, not equal to 9. It looks like all of the above are the correct answer. Number 6, how do you read this sentence? X is an element of real numbers such that 3 is less than or equal to x, less than or equal to 5. But equals means that it is inclusive. R says it's every single number, including all the little decimals. So therefore, we definitely have this one, the middle one. Next up, what is the difference between the number line graphs of these two intervals? 2 to 8, 2 to 8. Well, let's notice that we have a parenthesis and we have a bracket. The parenthesis says not equal to, so we're going to use an open dot. This one says a closed dot. Everything else is going to be the same. The first graph has an open unshaded circle at 2, while the second has a closed. That is exactly what the difference is. Number 8. Which statement below is the correct interval notation for the situation depicted in this number line graph? We're going to have a solid or a bracket. That leaves this first one out. Then at 5, we have a parenthesis. That leaves this one out. At 0, we have a parenthesis, and then we go to +infinity. It is the third choice. By the way, if I'm going too fast as you were listening to this video, go back and replay the section, or write down what your question is on your notes and bring it in. This isn't supposed to be necessarily a flipped classroom as much as it is when you're absent. You have the opportunity to go back and review a lesson, or you can go back and just review the lesson before the test. Whatever it is that you need, it's a help, an aid. It's not the end all. So do make notes and ask questions. Now, number 9, write the following statement as an inequality. -infinity less than up to -3, or 0 up to 2, or 4 to infinity. And in this case, we can equal 0 and we can equal 4. So, x is less than or equal to, no, we've got an open bracket. And then the 0 has an equals, that's good there. The 2 has just less than, that's good there. 4 needs the equals. So therefore, we are looking at our third one. Number 10, write the following inequality as interval notation. So we're looking at it, we're going to have a bracket on -2, and then a parenthesis on 1. And then we've got an or statement. Okay, because we can't actually equal 1. So we've got a bracket, a parenthesis, and then a parenthesis, and then you're going to have infinity. This is our third option. Finally, number 11. Which interval notation represents the set of all numbers from 2 through 7 inclusive? Okay, inclusive means that it includes, so I'm going to need brackets. That would be my third option. Excellent job. Okay, let's keep going just a little bit more. And let's take a look at the fact that we need to do these. Write the following inequalities, okay, using interval notation, and then write these following interval notations using inequalities. Pause the video and try these, then come back and check your answers. Okay, so I'm going to go through these, showing you the answers and showing you how to write them out. First off, when you're going from an inequality to interval notation, look at the inequality symbols. We first write down a bracket. Well, maybe. We first write down a bracket and then the number. Instead of putting the inequality symbol in the variable, we put a parenthesis. Then we put the next number. Then we look up here and decide bracket or parenthesis. It's got an equals, so it's a bracket. Next up, I have 4, 8.5. Essentially, you can write the number, a comma, and the number. Then go back and I need bracket and parenthesis. Ooh, this one gets a little tougher. I would suggest anytime you're rewriting something from interval notation or from set builder notation or an inequality into interval notation, first turn it around so that it's in less than. This is -2 less than x. Okay. Now I can say I have -2, comma. Ooh, I don't have anything after the x. Well, that means I'll have an infinity. Because it's not equal to, it's a parenthesis and a parenthesis. This one's already in less than notation. So I write down the first number. There is no first number. So I'm going to use -infinity. Then I put the comma, and then I put the 7, and again there's no equals, so it's a parenthesis. And this last one, number, comma, number, and I go back, no equals, no equals, so therefore it's just parentheses. That's the way that you can mentally go through, figure out what it is you need to do, and write it out correctly. Okay? Right, let's look at this last group here. This one I'm going to reinsert the inequality in. Okay, so I've got -6 less than x. I've got to put the x back in instead of the comma, less than 4. How did I know it's less than? Because I've got parentheses. Next up, I have a number. Well, you don't write -infinity. I've got a comma. Oh, I put the variable in for the comma. And then I have 1.5. I'm going to use a less than. Next, number, x, number. This has got an equals. There's no equals. See how easy that is? Here we have -3, we have variable, we have number. There's an equals and an equals because there's brackets. Okay, notice the brackets tell me that I've got the equals. The numbers go here, and then the x, that's what our comma becomes. Finally, we're looking at this guy, and we have 8, and we have an x. We don't have another number, so we don't put anything out there, and it's a bracket, so it's going to be less than or equal to. That's it. That's all there is going from interval notation to set builder. Okay, I'm going to stop this part of the video since this is just with all the notation, and I'll do a second part of the video when we work on inequalities.